Alright guys, welcome back, and in this video we will be looking at how we can use templates in order to actually code a data type, and you will also see how type def is actually useful in this case. So let's imagine that we have a class which does a bunch of math operations. Let's call this math tools, like this. And so math tools has a public method called multiply. Let's see, and we basically give it 2 ints, and it returns us a times b. However, you remember we want to make this class generic. We want this class to be reusable across different data types. So for example, let's make this int math tools. So we are making a math tools class that works with integers, and you will soon realize the issue here. So let's see, we have multiply, we have divide, we have add, like this, and we have subtract, like this. So you see, now we have this class called int math tools, and I can make an instance. Let's see, math tools, like this. And now I can, for example, see out, and I can do math tools dot add 3 and 2. Let's see what happens. Let's see what happens if we did any errors. So 3 plus 2 is 5. It works beautifully. Now imagine the situation where I now want the entire thing here, but I want it for a double. You see, I mean, it is an issue because now I need to copy, I need to change this to double, and I need to change all of this to double, all of this. Imagine if I just want to have the same exact class, but I want to replace the type in all of the variables. I just want to add another type. It is a hell. I mean, you see how much code it is. This is not the way to do it. The way to do it is to use generics. So in order to use this, we write template and we write class T as before. And now this math tools class will be generic. It will be able to use whatever type you want. And we replace all the ints here with T, because this is what we have written here. Once again, we don't have to write T here, but it is standard to write T. So we replace all of the things here. And now when we create this class, we can actually specify what kind of type we want by writing this lesser and greater than brackets, like this. So when we write math tools and then brackets int, C++ will basically look here and realize, oh, actually this class is able to accommodate different types. And so now what we want to do is that we want to create this class, and wherever you have T, we want to instead replace it with int. And so this is how C++ will initiate this object right here. It will basically take this class and replace all of the T's with int. So let's see if this works. Let's see, build and run. We have some kind of issue here. Let me see. Let's see, math tools. Yeah, this is what happens when you do live coding, guys. Math tools. Is this the same? Yes. Math tools. Or actually, you don't have to do this. Just do this. Build and run, and you see 5. It works perfectly fine. Now if I do, for example, 3.3, it is still 5 because it only works with integers. So perfect. And let's say that this is our int math tools, but you realize that I can very easily create double math tools. I do double here and I do double here. And now all the T's here are now replaced with double instead. So you see how flexible we are. You see how flexible we are when it comes to different data types. And so now 3.3.2 is 5.3. So it actually works. We're able to define this data structure that can work with several different data types, generic data types. Now, something that I want to point your attention to is that now you kind of understand why we sometimes need type def. So here we can actually use type def to define, for example, we want to define, instead of writing math tools and then open bracket, int, close bracket, why don't we just have int tools like this, int tools. And then why don't we just have double tools instead of writing this? So you see, we can kind of make this more beautiful. We can make this code more cleaner. And imagine when you have a big code base, and maybe in generics here you have some other crazy thing here with person, and I mean it can really get whenever you have these generics and then maybe as type you have another data type which is also generic. I mean, these things can get pretty long. So this is why we can use type def, and this is how we can make alias. So int tools is basically math tools int, and double tools is math tools double. I'm just showing you guys why it is sometimes handy to have a type def, and why it's sometimes handy to replace complicated names such as this one with simpler names such as this one. So guys, I hope you understand, I hope you learned, I hope you know more about generics, and I'll see you all in the next video.